Students, in this video we will learn about the method of virtual work. So let us start. So what is principle of virtual work? It says that if a particle or a rigid body or system of rigid bodies which is in equilibrium under various forces is given an arbitrary virtual displacement, then the net work done by the external forces during that displacement is zero. Okay, so a particle or a rigid body or a system of rigid bodies when they are in equilibrium. Okay, so suppose if we are giving some virtual displacement, so because there is no actual displacement, that means the net work done by the external force during that displacement is zero. And this principle is particularly useful when applied to the solution of problems involving the equilibrium of machines or mechanism that consist of several connected members. Okay, and if a particle, rigid body or system of rigid bodies is in equilibrium, then the derivative of its potential energy with respect to the variable defining its position is zero. Okay, so now let us understand the work of a force. So suppose this is the force, okay, which is applied at point A, and suppose this particle under the action of this force moves to another point A dash, and these R is the initial position vector of the particle, and R plus dr is the final position vector, while this dr is the displacement vector. Then the work of this force will be given as F dot dr, means dot product of the force and displacement, and which we can also write as du is equal to F ds cos alpha, as you already know how to open the dot product. Now there are some situations when the both force and displacement is in the same direction, that means alpha is equal to 0, then this work is simply equal to the product of F into ds. Okay, while if this alpha is equal to pi, that means the force and the displacement is in the opposite direction. That usually happens with the weight force, which is because of the gravity. So in that case the W work is du is equal to minus F dot ds. Okay, and if alpha is equal to pi by 2, means the force applied, okay, and displacement, they are perpendicular to each other, means they have the 90-degree angle. So as we know that cos 90 is 0, so that means the work is 0. So this is very important. Whenever the force and displacement they are perpendicular to each other, then the work done will be 0. Okay, so now we will discuss some important forces which do no work. So first one is the reaction at a frictionless pin due to a rotation of a body around the pin. Okay, so this force reaction at the frictionless pin will do no work because there is no lateral motion, only rotation is there, so this force will do no work. Second, reaction at a frictionless surface due to motion of a body along the surface. So because this is causing a perpendicular arrangement, okay, because reaction at the frictionless surface is always perpendicular, and suppose this is the body, okay, and body is moving in this direction. So we can say that this is angle is 90 degree, okay. So whenever the force and displacement is 90 degree, then the work is 0. So in this case also the work is 0. Similarly, weight of a body with CG moving horizontally. So in this case also the weight which is act vertically downward while the center of gravity is moving horizontally. So again both the forces and displacement, they are perpendicular to each other and there will be a no work. Then friction force on a wheel moving without slipping. So again in this case, suppose this is the wheel and it is moving without slipping, okay. So the friction force will be always opposite to the motion, and this is the motion of the wheel, so they will always be perpendicular to each other. So again there will be no work, okay. Again, sum of work done by several forces may be zero apart from these conditions when bodies are connected by a frictionless pin. So as in this case, these two bodies AC and BC, they are connected by a frictionless pin. So there will be two forces, F and minus F. So if this force is doing a positive work, and then the work of this force is negative, and both the works add up to 0, okay. Similarly, body is connected by an inextensible cord, as in this case. So again, suppose if this is doing positive work, so then this will do negative work, then both the work will be, overall the work will be 0. Similarly, third case is internal forces holding together parts of a rigid body. So suppose this is the rigid body and these are the 2 points A and B, and we are having forces F and minus F. So these are the internal forces. So again, if we see from the external, there is no force. So in this case also, the work of these forces, internal forces, will be 0. Now let us see the work of a couple. Okay, so again consider the rigid body, and suppose these are the 2 points F, A and B, and the couple is acting on AB. So suppose this is F, this is minus F. So under the action of the couple, there are two type of motions: translation motion from AB to A dash B dash, okay, and rotation of B dash about A dash to B double dash, okay. So under the action of the couple, these two points A and B, they move to A dash and B double dash, and we can divide it into two parts: translational motion plus rotational motion, okay. So now this the translational motion, this will cancel out. So well, suppose we have minus F dot dr and plus F dot dr, so this will cancel out, and finally the work which will remain is only F dot dr2, okay, which is nothing will but F ds2, which will be equals to F r d theta. So if this is the vector r, so this is the distance r and this is angle d theta, then r d theta will be equal to dr2, and F into r is nothing but the moment. So work from a couple, we can say that will be equal to moment into the angular rotation of the body, m d theta. So this is very simple. We can calculate the work of a couple by this expression, W is equal to m d theta. Now what principle of virtual work says? So imagine a virtual displacement of particles which are acted upon by several forces. Suppose multiple forces are acting on the body. So the corresponding virtual work will be F1 dot delta R plus F2 dot delta R plus F3 dot delta R. So we will consider the work from every force, and then we will add that, so we will get the total corresponding virtual work. So now this expression we can write like this. We can take delta del r dot as common, then the work will be F1 plus F2 plus F3 dot delta r, and we can write the resultant of this, so the work will be R dot delta R. Now there are some points related to principle of virtual work. First is, if a particle is in equilibrium, the total virtual work of forces acting on the particle is zero. Because the particle is in equilibrium, it is not moving, so that means the total virtual work should be zero. Okay. And if a rigid body is in equilibrium, the total virtual work of external forces acting on the body is zero for any virtual displacement of the body. So if any rigid body is in equilibrium, then what we will do, we will calculate the virtual work and then we will equate it to zero, and then we can calculate any unknown quantity. And the third point is, if a system of connected rigid bodies remain connected during the virtual displacement, only work of the external forces need to be considered. So if there is some displacement in a rigid body which is connected, there are several rigid bodies which are connected, so we will consider the displacement only because of the external forces. Now how we can apply the application this principle of virtual work. So suppose this is a body, and there are two rigid bodies actually, AC and BC, and suppose this P is the external force which is acting, and this is the initial angle between this line and the rigid body is theta. Now suppose under this force, this body deform in this shape, so that this angle and this change in angle is delta theta, and this vertical movement in the vertical direction is delta yc, and movement in this axial direction is delta xb. Okay, so under the action of this forces and these reaction forces, these are the movements. So now you can calculate the virtual work. So virtual work will be delta uq, okay, plus means because of the force P, plus delta up because of the force P. Okay, so these P force and Q force, they will do work, and this is because this is the frictionless spin, so and the rotation motion is there, so these forces will do no work. Okay, now work because of the Q will be under the action Q. This is the displacement, and both are in the opposite direction, so this work is minus Q delta xb, and again this work is P delta yc, because this yc is negative, so minus yc. Okay, now we can write the expressions for xb. So this xb is nothing but 2l sine theta, because this part up to this point, sorry, up to this point is l sine theta plus l sine theta. So this xb will be equal to 2l sine theta, and then we can differentiate it. Then delta x will be 2l cos theta delta theta. Similarly, you can write expression for yc. So yc is l cos theta. Then we can differentiate. Delta yc is minus l sine theta delta theta. So now we can put these expression in this equation. So final equation of delta work, virtual work is minus 2ql cos theta delta theta plus pl sine theta del theta, and from this we can get the expression q is equal to half of p tan theta. Okay, so if we know this value of p, then we can calculate q, or if we know q, we can calculate p. So this is how we can do the problems related to virtual work. So thanks for watching the video. Have a nice day.